Hello everyone, this is Priyanshu Choubey, Assistant Professor of Suresh Gyan University. Today we will talk about minerals, silicates minerals, which is already the last video we already talked about it, discussed about it. Let's continue. Soil clay and clay minerals, already we talked about it. Any particles of less than 0.002 mm size is defined as a clay. A crystalline clay having a long range order in all the three dimensions is called a clay minerals. Common clay minerals belong to the group of layer silicates or aluminosilicates called phyllosilicates and oxide and hydroxides of iron, aluminium, and manganese and silicon. Beside these are there are non-crystalline clay such as amorphous oxide, hydroxides, and aluminum silicates. So, crystalline aluminosilicates structure principle. First one. So, layered silicates are most conventionally described as the combination of tetrahedral sheet formed by linking tetrahedral group like silicon oxide or octahedral silicates formed by linking octahedral group aluminum oxide in three-dimensional. I repeat again. Structure principle layer silicates are most conventionally described as a combination of tetrahedral sheet formed by linking tetrahedral group silicon oxide and octahedral sheets formed by linking octahedral groups aluminum oxide in three-dimensional. Clay minerals are combination of tetrahedral sheets and octahedral sheet in a 1:1 and 2:1. Tetrahedral seed is a combination of tetrahedral silicon groups and octahedral sheet is combination of octahedral aluminum oxide groups. A sheet is combination of plane of atoms and a layer is combination of sheet. A sheet is combination of plane of atoms and a layer is combination of sheet is 1:1 or 2:1. In addition, layers may be separated from one another by a various interlayer materials such as cation, hydride cations, organic molecules, and hydroxide octahedral groups. In tetrahedral sheet, each of three silicon oxide coordination groups share oxygen atoms with three neighboring oxygen silicon oxide groups. One oxygen shared with one neighbor only, which is called a corner sharing. This tetrahedral form a ring hexagonal activity. connecting six silicon and six oxygen. Each ring is joined to the adjacent ring through shear oxygen atoms. The oxygen atoms are approximately coplanar and are called basal oxygen atoms. This fourth oxygen from the edge of silicon oxide is the oriented normal to the basal plane. These are called apical oxygen atoms, which are also coplanar. The octahedral sheet is built up of aluminum oxide and magnesium oxide octahedral groups, which with each groups sharing a pair of oxygen with one neighboring group. This is called edges sharing, where of aluminum or magnesium cation share two oxygen atoms with the aluminum or magnesium cation in the adjacent octahedron. These are two ways in which this sharing takes place if all the octahedral sites cation, contain cation equivalent magnesium. Each share two oxygen atoms with each of six uh, neighboring cation. Magnesium. The sheet so formed is called as a trio octahedral sheet. On the other hand, if any two-third of the site contain cation aluminum and each aluminum share two oxygen with only a three aluminum. Three aluminum neighbors. The sheet is called as the dioctahedral sheets. Linking of tetrahedral sheet and octahedral sheet to form a layer. Linking of tetrahedral sheet or octahedral sheet is form a layer. Linking of tetrahedral sheet and octahedral sheet take place through the apical oxygen of the tetrahedral sheet. This plane becomes a common to both tetrahedral as well as octahedral sheet, and the connecting oxygen atoms is shared by both tetrahedral aluminum, silicon or aluminum, and octahedral aluminum or magnesium. The rest of the anion groups in this plane remain as hydride and belong only to octahedral sheet. Tetrahedral sheet is longer, b-dimensional than the octahedral sheet. During a linking of two sheets, the tetrahedral sheet must contract. This is achieved by two adjacent tetrahedral rotating is opposite direction as a uh, Consequence, the hexagonal activity on the tetrahedral sheet change its shape to diagonal cavity in real structure. It has a very important consequence of potassium bonding in the interlayer of mica. Stacking of layers, a number of layers thus formed as stuck together vertically, one after another from clay particles. This space between two ad- adjust layer is called interlayer space. The bond between the two stacking layers may be a different step, like van der Waal walls and pores in case of pyrophyllite and talc. Electrostatic attraction between a negative charge in the layer and interlayer cation in the interlayer, as in case of other two ratio 1 clay minerals. H bonding between hydrogen bonding between a OH group of one layer of oxygen group of other layer in the case of colonite minerals. Sometimes a solid seed may be present between solid sheet may be present between the two layers and attached with the two layers by electrostatic attraction between a negative charge in the layer and positive charge in the interlayer sheet, as in the case of electrochloride. Development of a negative charge in the layer, depending on the types of minerals. Portion of aqua driven silicon is tetrahedral seed replaced by a trivalent aluminum, or a portion of trivalent aluminum is replaced by a divalent magnesium ions in the octahedral seed. This is called isomorphous substitution. As a result of this, the negative charge develop in the layer. The amount of charge developed will be equal to the amount of substitution. For example, if one silicon ion is substituted by one aluminium ion in the formula weight of the mineral, it is result in the development of one equivalent charge of per formula weight. This layer charge is a very important property which determines its properties and classification status. So, principal structure group. There are five main structure group of layer silicates mineral which occur in soil as the clay minerals. First one, colionite separating group with uncharged 1 ratio 1 tetrahedral ratio octahedral layers. Pyrophyllite talc group with uncharged 2 ratio 1 tetrahedral ratio octahedral ratio tetrahedral layers. Mica group with a charged 2 ratio 1 layers, interlayer anhydride potassium. Uh, Semicistite and vermiculites group with charged 2 ratio 1 layers and interlayer cation whose hadrons state varies with the humidity. Chloride groups with a charged 2 ratio 1 layers and a positively charged hydroxide interlayer beside a layer silicates other minerals such as feldspar and silica may also occur in a clay section. Dioctahedral minerals of kaolinite groups. In each, the three minerals connected in this group, kaolinite and dicite and nacrite. One tetrahedral sheet is linked that its apical oxygen to an octahedral sheet, connecting two-thirds of this octahedral sheet occupied by a trivalent ions, aluminum ions. The linking oxygen belong to both tetrahedral and octahedral sheet. Other atoms in this uh, plane are hydroxide groups which belong to the octahedral sheet. These hydroxide groups are called inner or hydroxide groups and located vertical above the hexagonal cavity. Those hydroxide groups are placed at the outer surface of octahedral sheet as called the outer hydroxide. Uh, the unit cell of colonite in the Z, Y, or CB plane unit cell, the smallest three-dimensional section of minerals, which are repeats in all the three-dimensional edge. Along the z-axis, c-dimensional of the cell started with the plane of order OH group of octahedral sheet having a six OH groups followed by a octahedral aluminum plane. Oxygen, 4 oxygen plus 2 OH plane, a tetrahedral 4 silicon planes, and outer 6 oxygen plane, which makes a hydrogen bond with the hydrogen hydroxide planes of octahedral sheet of the next chloride layer unit. This distance from the OH plane of one unit to the corresponding OH plane is the repeated distance between distance along the C-axis and is called the C-axis spacing of the mineral in the planes of outer oxygen more than 6 oxygen or here. The oxygen with a cut bond share only half with the silicon in the unit cell. The other half is shared with the silicon of the other unit cell. Three are six such half shared oxygen and three full shared oxygen here. In this structure, total six oxygen. So if we calculate the total positive charge of the cations and total negative charge of the anions, it is in the unit cell like cation 4 aluminum is equal plus 4 into 3 is equal to 12 positively charged and anion 6 OH is equal to minus 1 and into minus 6, so minus 6 any negatively charged, and 4 aluminum is equal to 4 plus 4 into 4 is equal to plus 16 plus 16. Anion 4 oxygen plus 2 OH is equal to minus 2 into 4 minus 1 into 2 is equal to minus 10 is so 6 O is equal to minus 2 into 6 is equal to minus 12. So total 26 cations positively and total 28 negatively. So the net charge is 0 and the structure is neutral and the unit cell formula is silicon, aluminum, oxygen, confirming to the phyllosilicates formula of silicon pentoxide for the 1 ratio 1 trioctahedral. Uh, Structuring the ideal chemical composition is a magnesium silicon hydroxide. Uh, sur- mm, Strutting contains only divalent cations in the octahedral sheets. So, we have completed at a 1 ratio 1 the di-octahedral minerals of the kaolinite groups. Thank you. Mineral groups, silicates, mineral groups, iron oxide and hydroxides and ortho oxides. Iron oxyhydroxide formula is FeOH. Geothites alpha form is the most frequently occurring form in the every soil types of and climatic region and imparts a yellow-brown color of the soil. The other polymorphous and leptodecorites is the less common. These are usually formed from the oxidation of the precipitation of the ferrous hydroxide compounds, particularly in the hydromorphic soil, submerged soil. These are usually formed from the oxidation precipitates of a ferrous hydroxide group. Compounds are particularly common is a hydromorphic soil, submerged soil. Iron oxide, hematite, is the second most frequently occurring iron oxide in the soil after geothites. It imparts more pronounced red color due to soil. Its other polymorph, mega hamite, is especially common is a highly weathered soil of a tropical and subtropical climate and also occur in the temperate region. impart more pronounced red color of the soil. Its other polymorphous megahematites is especially common in a high weathered soil of a tropical and subtropical climate and also occur in the temperate region. It This ferrous magnetic minerals is a reddish brown in color, and magnetite may have same origin as a megahematite. This is also ferromagnetic. Magnetite is an addition of iron being in octahedral coordination. These two compounds also have a part of the iron and tetrahedral coordination. Ferrihydrite. This is found in the particular environmental associated with the soil, such as drain channels and the small, slow running water streams. It's looks as rusty, voluminous precipitate rich in adsorbed water and often rich in as adsorbed inorganic ions, organic materials. It forms a very small spherical particles with a high surface area. These oxides and hydroxides differ from the layered silicates mineral is that no parameters charge developed is them due to a isomorphous substitution. However, their surface develop a positive charge at low pH. Negative charge at high pH due to absorption of the hydrogen ions and disassociation of hydrogen ions on a form surface hydroxide groups. These surfaces are called a variable charge surface and are a very reactive with respect to absorption of ions, and consequently these are also possibility of the existence of unique pH value of at which the surface must show a zero charge. This pH is called zero point of charge, GPC. It's very important. I repeat again, what is the zero point of charge, GPC? Their surface develops a positive charge at a low pH and a negative charge at a high pH due to adsorption of hydrogen ions and this association of hydrogen ions on from a surface hydroxide groups. So these surfaces are called a variable charge surface and are very reactive with respect to adsorption of iron. So consequently, there is also a possibility of extension of the unique pH value at which the surface must show a zero charge. So this pH is called a zero point of charge. Other accessories, minerals, apatite minerals, these are most common phosphorus connecting primary minerals, predominantly occurring in the rocks and little weathered parent material. These are most common in basalt, less common in siliceous rocks. The different types of apatite present are the fluoroapatite, hydroxyapatite, and carbonate apatite. Carbonate and sulfide minerals. Carbonate, these are included calcites, uh, arangonites, and magnesites, and dolomites, and siderite. And these minerals are formed in subsoil of the subhumid region near a surface soil and arid region. Sulfate gypsum is a major mineral. Sulfate are also generated from oxidation of a pyrite. Pyrite on Moscovite pyrite and the marxite minerals. The general formula of iron FeS2O and marxite is sometimes called white pyrite, and is a polymorph having a different crystal system. Pyrite are formed in a soil under a reduced conditions where ferrous and iron come from a reduction of ferric oxides, and sulfides come from a reduction of sulfides and both iron and sulfide. So generated precipitate as a ferrous and sulfide. The ferrous sulfide upon aging with the time gets converted to a ferrous sulfide. These minerals are usually formed in the coastal area, which remain waterlogged by under the sulfur-rich sea water. With this soil the drained and exposed to oxidation sulfide oxides to generate sulfuric acid. This soil are called as acid sulfate soil. Sulfuric acid form the react iron aluminium bearing minerals and form a complex minerals such as the xerosites having a general chemical formula of potassium iron oxide hydroxide sulfide and potassium with aluminium, depending upon the predominated of iron and aluminium in soil solution, expressing oxidation. So highly resistant minerals, these minerals undergo a very little weathering and remain almost uh, and and intact with where other minerals undergo a weathering all the time. Thus, the friction of these minerals increase with time, and these minerals are used for the tracing the origin of soil parent material. These minerals include like tourmaline. Tourmaline plants cannot take any boron from these minerals. Epidotes, zircon, topaz, uh, garnet, rhyolite, and elamine. So identification of the minerals, uh, identification of crystalline minerals be X-rays diffraction. Crystalline minerals are identification by checking the inner planar distance of the diagnostic plane. For example, for the layer silicates, the diagnostic plane is the plane which passes through the interlayer positions. Like that, a plane which is parallel to x or y axis, but cut intercepts jet axis. So at the one C, thus the index Miller index of the plane is a 0.01. So actually, this index does not indicate the single plane, but indicates the set of parallel planes separated by the distance equal to a c dimensions. All of the interlayer All the interlayer planes have the same index 0.01. The interplanar distance of these parallel planes is expressed as the distance 001, which is equal to c dimension for the Kelvinite. The distance 0.01. So 7.2 angstrom. The interplanar distance of the diagnostic plane is determined by the X-ray diffraction method with the help of Dagger equation. So alpha is equal to distance sin where alpha is the wavelength of the X-ray used. Zero is the angle of incidence of X-ray on the concerned plane of the minerals at which the X-ray diffracted to get the high intensity of the X-ray is in the form of the peak. X-ray diffractions take place when the X-ray beams are spread in the particular direction simultaneously by the atoms in a parallel set of bands and get superimposed on each other. So when the Frame posed a scatters beam as the two parallel planes differ in their path length by a integer number 1, 2, 3, and like n of the wavelength and alpha their phase becomes same is that the crest of one wave falls the crest of the other, and the result beam is interfered, which is more than a layer of the diffract beam is called the constructive interference when the phase of the two beams are seen. There, the maximum displacement of the wave from the mean position are added up the result beam and since certain intensity of proportional to square or amplitude, the result beam becomes four times more intense than the original beam, and one gets the difference diffractions maximum and form the peak intensity. So similarly, at the certain angle, the path length and difference between a two supreme posing beams becomes is like n plus 2 up n plus a half. If then the crust of one wave falls on the throat of the other two. One where displacement channel cancels the other, and one get diffractions minimum. And the two beam of X-rays starting from a AB plane are incident at an angle 0 and scattered by two corresponding atoms in the two parallel planes spread by a interpanel distance d. PQ in and the supreme post at a CD planes. The path difference of two beams is RQ plus US, where PR and PS of are perpendicular at the BQ and QD respectively. Beam BQ has traveled more than AP at the CD planes. Diffraction maximum will be obtained. X-ray diffraction by crystalline minerals, X-ray scattering by atoms, and then interface derivation by Berg's equation. Genesis and transformation of clay mineral. Genesis means a resynthesis of a clay mineral from a weathering product, primary or secondary minerals, the silicate minerals such as olivine, pyrohexane, and um, amphiboles group of minerals, weathered relatively easily than the other silicate minerals. So decompose completely given rise to accumulation of negatively charged colloidal silica and positively charged colloidal aluminum or iron oxide basis cations such as sodium, potassium, calcium in a soil solution. Silica and aluminum may also come from a weathering of other silicate minerals such as feldspar, but to a lesser extent. This negatively charged silica and positively charged aluminum react at different proportion depending on their relative abundance of concentration, which in turn depends on the prevailing rainfall in that area, which leach down more of silica than aluminium. Thus, in a dry area where more silica and more base cation are available, 2:1 types of minerals will be synthesized, whereas under high rainfall condition more silica or a base will leach down 2:1 types of minerals such as kaolites will be synthesized. In the synthesized minerals no sign of the parent material is found, so transformation of alterations in is the process in which the basic skeleton of the minerals remains the same, but one clay minerals is transformed to another clay minerals having a different layer charge. So different particle size, different base cations, and different amount of water. So phyllosilicates undergo this process of transformation. For example, mica's transformation in uh, hydromica, elites, vermiculites, montmorenolites. Genesis of clay minerals like olivine, pyrohexane, and amphiboles. So decomposed completely and goes completely. These are minerals are completely decomposed. So these are colloidal silica, colloidal aluminium bases, hydros, oxides of iron and titanium. So feldspar partially decomposed. Partially decomposed, so also oxides of aluminium, of iron and mm, titanium. Uh, Olivine pyrohexane and amphiphos decompose completely. So again, resynthesize with no silica, crystalline oxide, aluminium, iron, and titanium. Resynthesize with less silica, colonite, and resynthesize with more silica is semicides. Mica availability 10% potassium, but hydros mica potassium availability 6 to 8%, and uh, elite potassium availability 4 to 6%. Transitionally, clay minerals are having a layer of elite and vermiculites and montmorillonites in the same particles. Potassium is 3%, vermiculites less than 1%, and montmorillonite less than 1%. So, increase in water content, specific surface area, decrease in layer charge and particle size. So layer silicates clay minerals in Indian soil. Clay minerals present in the dominant group of the soil of an Indian soil, as like alluvial soil. So alluvial soil dominate 50 to 60% clay minerals present in the alluvial soil is a elite. The other mineral present are the kaolinites and chlorites and simicides. So some soil in older alluvial soil contain the appreciable amount of simicides minerals. Black soil clay minerals presenting 70 to 80%. So this group of soil belongs to a simicide group. The other clay minerals present are the elites and kaolinites. Red and lateric soils. So clay minerals are presenting 70 to 80% present in group soil in kaolinite. The other clay minerals present elites, kaolinites, semicide means layer minerals are semicide. So properties of soil clay. The clay particles present in soil often are were appreciably in properties from the pure minerals. These minerals have a less well ordered structure and are smaller in size. The surface of clay particles in many soils are not clean but have films of iron and aluminum hydroxides. Soil properties associated with the positively charged surface are due to these one properties are described like a specific surface area. The specific surface area of the dominant soil clay minerals is also follows. Well, dispraised sodium montmorillonite 700 to 800 milligram vermiculites are mixed layer minerals 300 to 500 mica clay 100 to 300 and collinite clay and 5 to 100 milligram. These amorphous constitutes aluminum and ferric hydroxide gel have a specific surface area ranging between 100 to 5 milligram. Cation exchange capacity. Properties of soil clay is that is very important. Cation exchange capacity. Cation exchange capacity of the mm, my miqueous clays varies from 30 to 40. Cation exchange capacity of the miqueous clay varies from 30 to 40 centimole per kg inverse of the clay Montmorino from 80 to 120 centimole clay minerals vermiculites up to 152 centimole per kg inverse of clay soil kaolinite and halocites having a cation exchange capacity varying from a 3 to 5 centimole per kg inverse. The sometimes 20 to 30 centimole kg per inverse of the clay when very small light particles are the absorbed on the broken edges of the kaolinite piece. So he have completed highly resistant minerals, pyrite and the marxite minerals and other accessories minerals, apatite minerals and carbonate and sulfide minerals. And also identification of crystalline minerals by X-ray diffractions. That is the most important thing about identification of crystalline minerals. Also involved in Miller induction of the plane. And diagnostic plane of clay crystalline minerals and genesis and transformation of clay minerals layers liquids clay minerals in the Indian soil like alluvial soils which types of minerals are dominant in alluvial soil and black soil in dominate to sematites group like clay minerals light and colonites and red and light laterite soils are belongs to a colonites clay minerals other presenting colonites and sematites mixed layer minerals are the sematites and properties of the soil clay are properties like a specific surface area and cation exchange capacity. So we are completed about minerals. In next soil we will discussed about soil colloids. Oh.